So 4 times 4 is 16 minus 36i plus 36i minus 9i squared. Make sure you're okay with what we just did there. Does that make sense? Something cancel? What? Yeah. And what is I squared? So you end up with 16 minus, 16 minus 9 times negative 1. So what is that?
Shouldn't it be
negative 81.
Negative 81?
Yeah, because it should 9 times 9 be 81, not 9.
Oh, I can almost do some basic math. Almost. Correct. So yes, that should be 81. So what do you end up with? 16 plus 81, which is 97.
Wait, so could you
To do something different. X plus
3i
mm-hmm.
x minus 3i?
X minus 3i, correct. Yeah, there you go. Good job.
But what we got was 97.
Yes, correct. Okay, what's your only thing you can do right there? You could subtract 1, or you could just leave it like it is, because I like positive things better than negative things. So what do you do at this point? Yeah, just square both sides. So the left side, remember, is the square root of 11 plus 2x plus 1. Square root of 11 plus 2x plus 1 equals, and what does the right side become? Yeah, square root of a table times the square root of a table is a table. So then you have to FOIL this out, not just square each individual element, and end up with 11 plus 2x plus 2 of them, right? Plus 1 is equal to 5x plus 1. At this point, so we multiplied, we're going to clean up. You need to clean up before you FOIL again, so you need to combine like terms. Are there some things that can be combined on both sides? So you have a 12, so that takes care of those two, right? You could cancel that and make that into a 3x. So you end up with 3x plus 1 and plus 2 root 11 plus 2x, right? What could I subtract from both sides now? 12, I like that. So you end up with 2 root 11 plus 2x is equal to 3x minus what? So what should you do at this point? You could, but I'm telling you, you don't need to, because you can avoid it. You can just square at this point and keep it out of fraction land. If you squared at that point, what's 2 squared? 4, and the square root absorbs equals, and then you have to multiply this out. It's going to be what? 9x squared minus 66x plus 121. They're bigger numbers, but that's just kind of the truth of the matter. Now what do you do on the left side? Distribute, so you get 44 plus 8x is equal to 9x squared. So what kind of equation do I have now? What kind of equation? It's a what? That's a quadratic. So at this point, when we have a quadratic, what do we do when we have a quadratic? Set it to 0, exactly. So you end up with 0 equals 9x squared, and then instead of minus 66, it's 66, negative 66 minus 8, minus 70 what? 74x. And then it's going to be plus what? 77?
Yeah.
So at this point, you do have a quadratic. It is equal to 0. So at this point, what's that word that we like to apply here? You want to factor, and you look at this, and you're kind of, I would imagine, sad. When you look at that, you're sad for a few reasons. One, the leading coefficient isn't what?
1.
We love it when it's not 9. And not only is it 3 and 3, 9 and 1. And then in addition to the 9, what else do you have there? You have the negative 74 and the 77. So this is where you want to be really careful and make sure you check things real carefully. Did anybody successfully factor this? We did it in class. So the answer to the question is, did we successfully factor this? We did in fact. We did in fact factor. Does it have a nice factorization?
Yeah.
It does. I think it breaks up into 9 and 1 as far as I remember. I think it was 9 and 1. Okay. But I think we ended up with the same. So I think it's 9x and x. And then what do these two have to multiply together to get? And luckily, there's only a couple ways to do that, right?
Yeah.
11 and what?
7.
So, one of them has to be negative, right? So negative 11 plus what? Well, that's not really going to make it 63 minus, that's close, right? So what should we make it? What do you think? So maybe make it plus this and minus this. Is that going to work? Well, not really, because then this is going to be negative, so they both have to be negative. Exactly, so they both have to be negative. It's 77, but this is negative, right? So they multiply together, they get 77, but you have to build a negative in middle term, so they both have to be negative. So does that work? Let's test it out. 9 times x is 9x squared, then you get minus 63x minus 11x plus 77. Oh, does it work? Oh, look at that, it does work. So now we know that either 9x minus 11 equals 0 or what?
X minus 7.
Exactly. So therefore 9x equals 11, x equals 11 over 9, or x equals 7. So you have this and that. Those are two potential answers. What do you theoretically have to do at this point? You need to check your answers. We're not going to do that right now. We did the bulk of it, but you need to check. Because are you guaranteed to have either one of them work? No, they both could not work. One of them could work. Or both of them could work. Expression. It's an expression. It doesn't have an equal sign. So how do we do this? Can someone explain to me how we do this? Yeah, you want to combine the terms that you can combine in it. Since it's division, what do you do with the exponents? No, you could, but what do you do with exponents? Like, what is a to the n over a to the c? That's a to the n minus c. So what do you do with exponents? You subtract them. So it's going to be x to the negative 2/3 minus what?
Minus negative 5/3.
Minus negative 5/3. Correct. You subtract again. Subtract. And then you have y to the 4/5 minus what?
Minus negative 2/3.
Fifths. 2/5. Minus 5/3 equal to? It's equal to what? Well, this make it 3/3. And then y to the what? Y to the what? 6/5. Sorry, this got a little pushy or something like that. I don't know what's going on. 6/5. What's 3 over 3? So it's going to be x, y to the 6/5. And now you're done. Now you're done.
What about the fraction, the mixed fraction 2.5?
Leave it like that. Leave it like that.